In this video, we'll start section 3.4 on combining functions. So our goals for this section are to combine functions by adding, subtracting, multiplying, dividing, and composition. And composition is what we'll really focus on when we put a function inside of another function. And then the second goal is to simplify and find the domain of compositions of functions. Okay, so I want to start with how to combine functions. So for this, I want to do an example. So let's let f of x be equal to x squared and g of x be equal to 3x plus 2. I want to evaluate each expression. So in part A, it writes f plus g in parentheses, and then it writes this parentheses x. Well, that just means that f plus g is what I'm calling a new function. So the way we're going to define this function is it'll mean f of x added to g of x. So if I add my two functions, I get x squared plus 3x plus 2. And that is the addition. So that is my two functions added. And I won't worry about simplifying or factoring for this. So this is my addition. Okay, for b, I have f minus g in parentheses and then parentheses x. So this will mean f of x minus g of x. Okay, so when I subtract my two functions, I will get x squared minus all of g of x. So when I minus all of g of x, I got to put a parentheses around it. And then 3x plus 2. If I don't put that parentheses, I'll forget that this negative applies to both of these terms. I got to distribute it now and get x squared minus 3x minus 2. All right, so that is the subtraction. In part C, we have fg like this in parentheses. That'll mean let's multiply the two functions. So f of x times g of x. If I multiply them, we get x squared times 3x plus 2. So that's my multiplication. I'll leave it like that. Okay. If I were to distribute this, that's actually less simplified. This is actually more factored here. All right, and finally, let's see, in D, we got f over g in parentheses and then parentheses x. This means to divide the two functions. So we do f of x over g of x. And dividing them, I get x squared on the top over 3x plus 2 on the bottom. Okay, so that's our division of functions. So now we're going to talk about some more interesting stuff. So we'll talk about composition of functions. So composition of functions. So in E, we have f, this circle, and then g of x. This is called the composition of functions. So this means I do f and then of g of x, which means I'm going to be plugging g of x into f. Okay, so anywhere I have the x in my formula for f of x, I'm going to be plugging in what g of x is. Okay, so this will give us f of, what was g of x? It was 3x plus 2. So let's remember f of x equals x squared. All right. All right, so whatever's in the parentheses, in this case it's 3x plus 2, that's what I got to plug into my formula for f of x, where my variable x is. So that'll be 3x plus 2 squared. All right, so that's our composition here. And if I switch the order, if I do g of f of x, so this is g of, and I'm plugging f of x into g. All right, so remember g of x is 3x plus 2. So this is g of, and my f of x formula is x squared. So this means, so whatever's in the parentheses, in this case it's x squared, that's what I gotta plug into the formula now for g, where my variable x is. So this x gets replaced with x squared. So I will get 3 times x squared, and then plus 2. All right, and that's the composition in the opposite direction.